You have probably heard the claim, the trivia fact, that there are more stars in the universe than grains of sand on Earth's beaches. On its face, it sounds like poetic exaggeration. Our brains are not built to process quantities that large, so we brush it off as a neat metaphor rather than a literal physical count. To find out if this is actually true, we have to strip away the poetry and lock down the math. And that starts with establishing a hard numerical baseline for the sand here on Earth. This model highlights every coastline and desert on the planet. By estimating the average width and depth of these sandy regions, geologists calculate that Earth holds roughly 1 billion grains of sand. That is a 1 followed by 18 to 19 zeros. The rules of our investigation are simple. For the trivia fact to hold up, the total number of stars out in the cosmos must mathematically surpass that massive earthly baseline. If the seemingly empty night sky beats the physical density of Earth's crust, then our human perception of physical reality is scaled entirely wrong. Earth is tiny compared to Jupiter, which is 11 times wider. The Sun is 10 times wider than Jupiter. Now look at the hypergiant Stephenson 218. Our Sun is reduced to a single pixel, holding 10 billion suns. As incomprehensible as that size is, Stephenson 218 is still just one individual object floating within a much larger system. When one solitary star can swallow 10 billion of our suns, the aggregate volume of all the stars in existence quickly breaks down our standard logic of how physical space works. To count them all, we have to pull back from individual stars and look at galaxies. Our own Milky Way contains hundreds of billions of stars by itself, but the Milky Way is just a drop in the ocean of the observable universe. In astronomy, this term refers strictly to the spherical region of space that humanity can currently map, measure, and see from Earth. This observable space reveals a web of 2 trillion distinct galaxies. Each node is a galaxy, housing hundreds of billions of stars. Multiplying these yields 1 septillion stars, 10 to the 24th power, a 1 with 24 zeros. Compare that septillion to the 1 billion grains of sand we counted back on Earth. The math is decisive. For every single grain of sand on every beach and in every desert on our planet, there are hundreds of thousands of stars in the night sky. That old piece of trivia is a mathematical certainty. The entire scale of human reality, down to the tiniest speck of crushed rock, is infinitesimally small compared to the observable cosmos. But our investigation is not over, because that staggering victory of 1 septillion stars represents almost nothing of the true reality. This diagram shows the limit of our vision. The observable universe is just a temporary bubble defined by the speed of light. We can only see the light that has had enough time, 13.8 billion years, to actually reach Earth. And the universe did not wait for that light. Shortly after the Big Bang, a mechanism called cosmic inflation expanded the universe exponentially faster than the speed of light itself. Because of that rapid expansion, objects were pushed far beyond our visual horizon. Inflation models suggest the true universe is at least 3 times 10 to the 23rd power, larger than the bubble we can actually see. Factoring in that unobservable space, physicists calculate the entire cosmos could contain over 10 to the 100th power stars. We started by trying to comprehend the sand on our beaches. Now we are faced with a universe so vast that our entire planet is less than a single grain of sand compared to the whole. We exist as fractions of dust floating in an ocean we can barely see. Yet humans are the only known entities in all that space capable of doing the math required to realize it.